Welcome to The Explainer. Today, we're taking our animated medical student character on what I can only describe as an epic quest to absolutely master systematic literature searching. Because, whether you're a med student, a researcher, or a clinician out in the field, finding the right evidence, that's the bedrock of modern medicine. But let's be real for a second. The databases we use every day can sometimes feel like totally impenetrable beasts. Okay, let's just dive right into it. We've all been there, right? You've got this burning clinical question, you type a few hopeful keywords into the PubMed search bar, you hit go, and you just kind of cross your fingers. You're just praying the exact paper you need magically floats to the top of the list. It's the classic, and honestly pretty stressful, type and go method. And boom, you're hit with 8 billion results. Okay, all right, maybe not literally 8 billion, but you know exactly what I mean. You are instantly drowning in this overwhelming sea of unread, completely irrelevant articles. It's way more than you could ever read in a lifetime, and it makes finding that one crucial piece of evidence feel literally like finding a needle in a massive digital haystack. But don't panic, because this explainer is essentially your treasure map out of the chaos. We're going to cover 1. The PubMed overload problem. 2. Structuring your clinical question. 3. Building your concept grid. 4. Mastering mesh and syntax. And finally, 5. Refining to reduce bias. Number 1. The PubMed overload problem. So let's look at the central conflict here, that monster of information overload. Why does the traditional type and go method fail so spectacularly? Well, the literature actually tells us that without a systematic approach, creating an exhaustive search strategy is incredibly daunting. For systematic reviews, traditional searching can reportedly take 100 hours or more. Honestly, who has 100 hours for that? It's a massive pitfall for medical research, especially when time is tight and missing just one key trial could completely alter clinical guidelines. Which brings us to number 2, structuring your clinical question. To defeat this overload monster, we absolutely need a blueprint. Now, PICO, patient, intervention, comparison, outcome. You know it. It's the gold standard for clinical therapy trials. But it is not your only weapon. PICO, for instance, is perfect for observational exposure studies, like if you're looking at the effects of PM 2.5 air pollution on asthma. And if you're diving into qualitative research, the SPIDER framework handles those complex, experiential topics beautifully. But here's the catch, and this is a big one based on the Erasmus University method. We shouldn't just use every single element we've brainstormed. We have to prioritize our search elements based on how specific and important they are. Think about it. If you throw every single PICO element into your search bar, sure, you optimize for precision, but you completely destroy your recall. You are going to miss perfectly good papers just because they didn't explicitly mention the comparator in their abstract. Let's move on to number 3, building your concept grid. Once we have our high-priority elements, we use this magical tool to bridge the gap between human language and clunky database terminology. It's the concept grid. You literally just list out your core concepts at the top. Then, underneath each one, you brainstorm all the synonyms, spelling variations, and controlled vocabulary terms. For example, telemedicine naturally expands into telehealth and remote monitoring. You need all of these because different researchers around the world use totally different words to describe the exact same thing. And hey, keep this golden rule in mind. Keep your elements low. Over-restricting your search by adding overlapping, unnecessary concepts is a massive trap. Say you're already searching for the highly specific Liechtenstein technique for surgery. Adding another element for inguinal hernia just messes you up. Adding unnecessary elements drastically increases the chance you'll accidentally filter out vital, practice-changing evidence. All right, number 4, mastering mesh and syntax. So now we take that grid and we translate it into the machine code of the database. It's kind of like using syntax as a secret spell book to command PubMed. We take our human question and turn it into a highly sophisticated string. We use the Boolean operator OR to group all those synonyms we found, and to combine the big main concepts. Plus, we combine mesh, those are the medical subject headings, the database's controlled vocabulary, with free text words searched right in the title and abstract. You'll see that written out as the TIAB field tag. To see what a professional gold standard syntax string looks like out in the wild, look no further than the Cochrane Highly Sensitive Search Strategy. It is absolute gold. It methodically stacks publication types, mesh terms, and free text words, stuff like randomly or placebo, to make absolutely sure no randomized controlled trial slips through the cracks. It really is a masterclass in balancing sensitivity with precision.
Finally, number 5, refining to reduce bias.
For this final step, you have to put on your detective hat. You have to make sure your search is objectively exhaustive and totally free of accidental bias that could skew your clinical conclusions. Because honestly, the words you pick matter so much. Say you're researching prolonged breastfeeding. If you explicitly search for terms related to duration, you will unintentionally filter out negative studies. Why? Well, studies that found a positive effect are way more likely to boast about time factors in their abstracts. So by searching for duration, you're essentially silencing the negative evidence without even realizing it. So how do we fight these invisible biases? You systematically combine mesh with free text words to cast a wide net. You generally want to avoid the dangerous not operator because it loves to accidentally remove highly relevant records. And always get a peer review of your strategy using the PRESS checklist, that's the peer review of electronic search strategies, to ensure your search is structurally sound. Oh, and once you finally have that unbiased list of papers, your last job as a clinical detective is evaluating the quality of that evidence using formal risk of bias assessments like the Cochrane tools. Let's wrap this up with some truly actionable items you can take straight back to the lab or the clinic. I want you to commit to the one page, one file, one habit rule. 1 page, map out your concept grid before you even touch the keyboard. 1 file, keep a detailed search log of your strings and hit counts so your work is actually reproducible. And 1 habit, religiously check your reference manager output to make sure your citations are totally clean. By making these frameworks your baseline, you're going to save time, reduce bias, and drastically elevate the quality of your research. So I'll leave you with this. Are you going to keep fighting that 8 billion result monster barehanded, just hoping you stumble on the right paper? Or are you ready to use these tools to become a master literature detective? The choice is entirely yours. Thanks so much for joining me in this explainer, and happy searching.